So what is a polar coordinate? A polar coordinate is a plot of 2 points. So you have your radius, for example, maybe 3 and 2 pi over 3. Or maybe you have 6 and 7 pi over 6. So this point right here, that is the radius, and then you have your angle or your radians. So right there. Okay. And so basically, how are we gonna plot these? How would you plot this on a polar coordinate circle or a unit circle? So here we go. Unit circle usually has a radius of 1 right there. But for unit circle, it depends on what it is, but it can be like this. And it could go 1, 2, 3, 4, 5. So in particular, this unit circle would have a radius of 5. I'm gonna do one more circle. Now it has 6. Okay. Now, so how are we gonna plot the point 3 comma 2 pi over 3? So first you're gonna go to the radius. The radius is 3, so you're gonna go to 3. And then what is 2 pi over 3 on the unit circle? 2 pi over 3 is 1 pi over 3, 2 pi over 3. So it's gonna be on the 3 line at 2 pi over 3, right there. And what about 6 comma 7 pi over 6? So that is going to be pretty similar, except we have a radius of 6 and the angle measure is 7 pi over 6. So you're gonna go to 6 and then you're going to go 7 pi over 6. So we're gonna go 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So it's going to be right here, and you're going to go to 6, and then 7 pi over 6, right there. So that's how you plot a polar coordinate. You have your radius, and then you have your angle measure.
So problem 2 is what's another way to write 2 comma pi over 4 in polar coordinates? And so we start at the point here. That's our base point. And then one way to write it is go to 5 pi over 4 directly across. And then if it's negative 2, 5 pi over 4, since it's negative, we go from 5 pi over 4 at the origin and then step back by 2. And then another way we could write it is 9 pi over 4, because we go around by 8 pi over 4 and then another to pi over 4, and then it's the same point by 2. And then a third way we could write it is 2 negative 7 pi over 4, because it's down here, 7 pi over 4. So when we go around positive, we end up here. But if we went around negative, it goes around the opposite way, ends up at pi over 4, and then we go over 2. And that's 3 ways we can get to the same polar coordinate.
Next problem, we are going to go over converting polar coordinates to rectangular coordinates. So first off, let's get our point. Let me finish this unit circle really quick. Okay, so we're going to be working with 2 comma 5 pi over 4. So remember, this is our radius and this is our angle measure. So first thing you're gonna do is you're gonna plot this on the coordinate plane, or you don't have to, but I'm just gonna do that to like get a visualization. So we're gonna go pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and then the radius is 2. So we're gonna go 1, 2. So our point is right here. So first thing you wanna do to find the rectangular coordinates, so rectangular coordinates are in x, y form. So we're gonna find that here. So how to find that is you do the cosine of this angle and the sine of this angle. So remember, the cosine is the x value, sine equals the y value. So let's find the cosine of 5 pi over 4. Cosine of 5 pi over 4. And that is going to be negative square root of 2 over 2. Now that is our x value for this point. So we're gonna go right here, let's plot that. Square root of 2 over 2. And now let's find the sine of this point. So we're gonna do sine of 5 pi over 4, which equals negative square root of 2 over 2. So we're gonna put that right here. But this is not, we're not done yet. The radius for this particular point has a radius of 2, but when we go to the unit circle only has a radius of 1. So we need to match that radius to this point. So what you're going to do is you are going to multiply each of these points by the radius. You're going to multiply it by 2. So let's do that. 2 times 2. And since each of these are the same points or the same numbers, I'm just going to do it one time and then double it. So that equals negative square root of 2. So our rectangular points are going to be negative square root 2 and negative square root 2.
Problem 4 is a complex number has the rectangular coordinates 2, negative 2. How can we express this using its polar coordinates? So we're given 2, negative 2, and we can write that as 2 minus 2i. So to get this into rectangular coordinates, we need to transfer it to this, and first we have to find the magnitude. So we can turn this into 2 squared plus negative 2 squared, because the square root and the square cancel out, so we can just do this in the square root. And then we have 8, which can turn into 2 square root 2. So that's how we find our r. And then the next part is where we find the angle. And we can write this as tangent to the negative 1, so that's inverse tangent, times negative 2 over 2. And that is equivalent to just tangent inverse negative 1. And we can also write that as negative pi over 4 using the unit circle. And then now we have this and we have this, so we can split up the angle and then find our answer as 2 square root 2 cosine negative pi over 4 plus, let's go down, plus I 2 squared sine negative pi over 4. And this is our answer.